Velocity, a 9th grade conceptual physics video. This is Apple Drop by Harold Edgerton. Looking at this picture, where does the apple have the greatest displacement? Where is the apple moving the fastest? The apple has the greatest displacement per time at the bottom, where the images of the apple are farthest apart. It should make sense that the apple also has the greatest speed, as it is near the bottom of the drop. Mathematically, velocity is described as delta x over delta t, the change in position divided by the change in time, also known as the displacement divided by the change in time. We use x and vx when we're talking about the horizontal position and velocity. We use y and vy when we're talking about the vertical position and velocity. So delta y over delta t would indicate a vertical velocity, vy. Delta always means final minus initial, so delta y equals y final minus y initial, and delta t equals t final minus t initial. Generally, the initial time is 0. Our apple is falling vertically, so that's what we will focus on. If the apple is at position 5 meters at a time of 0 seconds, and it moves to position 0 meters by a time of a half a second, what is the apple's velocity? The displacement is y final minus y initial, or 0 meters minus 5 meters. The change in time is 0.5 seconds. So Vy equals minus 5 meters divided by 0.5 seconds, or negative 10 meters per second. Negative velocities indicate that you are going down, or left, or west, or south. What if the apple is at the position 10 meters at a time of 0 seconds, and moves to position 0 meters by a time of 1.5 seconds? What is the apple's velocity? Pause the video and figure out the initial position, the final position, the initial and final times, and velocity in the vertical direction before checking your work by continuing. The displacement, y final minus initial, is 0 minus 10. The change in time is 1.5 seconds. So Vy is negative 10 divided by 1.5 seconds, or negative 6.67 meters per second. Now let's look at a real situation from the photograph. You can impose a number line wherever you want. Sometimes it's easiest to set the origin on the floor. Sometimes it's easiest to set the origin at the initial position of the motion. Here we will set the origin where the ball is initially dropped. We want to get the data from this composite image. First, we'll use the image to get positions for each of the apple images. Each flash is the same time apart. I do not know the exact flash rate of this image, nor do I have a valid height scale, so we will assume the images are each 0.1 seconds apart and the scale is in centimeters. Looking at the images of the apple, we assign a position for each apple. We assume each is the same time apart. This means our times will go up by 0.1 second. That was our flash rate, so our times are 0, 0.1, 0.2, 0.3, etc. At the beginning, the apple is at position 0. Next, the next apple I see seems to be at a position negative 10, then a position negative 20. We have negative positions because we're going down. Notice, if we make a graph of this position versus time data, that the origin is on the top left corner of the graph. This is because the apple is falling. Also, notice the graph isn't really a straight line. Do you think the apple is slowing down or speeding up as it falls? Let's calculate the velocities from our position data. To calculate the velocities of each change in position, we need to remember the velocity is final position minus initial position divided by final time minus initial time. So for the first box, the change in position is negative 10 minus 0, and the change in time is 0.1 minus 0. That gives us a velocity of negative 100 centimeters per second. It makes sense that it's negative because it's going down. For the second velocity, negative 20 position minus negative 10, divided by the change in time for that step, 0.2 minus 0.1 seconds. We get negative 100 centimeters per second as well. Filling in the velocity column, we should notice that the velocity increases. This means the apple is getting faster. And all of our answers have to be negative because the apple is going down. To get the times that go with those velocities, we want the mid time, which is basically the time in between the two times. So between the beginning of the section and the end of the section. So for the first one, I want the time between 0 seconds and 0.1 seconds. The middle of that time is 0.05 seconds. The velocity we calculated is most accurate at this instant, which is the time between the starting and final time that we calculated the velocity. When we graph our velocity data, we can see it looks like a downward trending line, sort of. This velocity is getting faster as the negative numbers are going away from 0. Our initial velocity, according to the trend line, was around 0. And our final, we go further, our velocity gets more and more negative. The position versus time graph shows a curve. The line gets steeper as it goes down. This means that the apple is falling faster as it goes down. The velocity versus time graph kind of has 3 levels of speed. The apple is falling faster as it goes down. Had we taken our data more carefully, we would see a much more linear velocity graph and a more curvy position graph.